My name is Miles, and today I'm going to be explaining how a 3x2 memory circuit works that I had to build for the TEJ 4MO computer engineering course. Now, this memory circuit was constructed using three 7474s, which are more commonly known as commercial D flip-flops. So this one is a D flip-flop, this one and this one, these are D flip-flops. I had to use six 7408s, which are AND gate IC chips. These three and these three are your AND gate IC chips. I had to use one OR gate IC chip, which is more known as a 7432, this one. I had to use a 7414, which is more commonly known as an inverter IC chip up here. And then I had to use red LEDs, which are connected to the address location of 10. These yellow LEDs to indicate which D1 and D0 are on for the address 01. And then these clear LEDs are actually green LEDs, and they're going to do the same thing but for the address 00. And then finally, these two blue LEDs are used for the read outputs. And then another feature added on is the inclusion of this push button that's supposed to simulate a clock pulse, along with a couple of loose wires that are used to indicate the D1, which is this, D0, which is this wire, A0, which is the black one, the red wire is A1, and then this is your read and write. Now, at first glance, when you look at the circuit, it may seem very daunting and complex, but when you look at it through the point of view of a computer engineer, it unveils that a combination of logic gates are working in a simple manner and together to allow the circuit to function
So
properly.
as you can see, what I've done is made a schematic of the 3x2 memory circuit with the modifications that were required for the situation of this project on crock clips. Now, I like to think of the 3x2 memory circuit as a bunch of smaller circuits that are working together in order to perform the function properly. So, for example, I like to think of this entire section with all the AND gates and the inverters as part of the address bus section along with the clock output. I like to think of this next section, so all these LEDs and the commercial D flip-flops along with their D0 and D1 inputs as part of the data switches section. And finally, I like to think of this massive section with all these AND gates and all these OR gates along with these two LEDs as part of the read and write section of the circuit. Okay, so I will start explaining how the address bus works. Now, the function of an address bus is to determine which memory cell will have data stored into it. Now, originally, these three AND ICs were only supposed to correspond to memory location 1, memory location 2, and memory location 3. In memory location 1, A0 was supposed to be positive, A1 was supposed to be negative. In memory location 2, A1 was supposed to be positive, A0 was supposed to be negative. And in memory location 3, both A1 and A0 were supposed to be positive. But I was asked for this project to modify it so that now this is address 00, this is address 01, and this is now address 10. Now, since this is supposed to be memory location 0 or address 00, that means that both A1 and A0, both A1 and A0 have to be negative. But the thing is, since these three are all AND ICs, the only way they'll turn on is if both of their inputs are positive. And since this is memory location 00, both inputs have to be negative. And the only way to convert these negatives into positive is to add an inverter. So that's why I did from memory location 1 to turn into memory location 0. Now for this one, this was originally memory location 2 and now it became memory location 1. And in this case, A0 is supposed to be positive, right? As you can see. And A1 was supposed to be negative. Now since A0 is already positive, you can connect it directly to one of the inputs of the AND gate, but since A1 is negative, you have to add an inverter to invert that 0 into a 1, so therefore the AND gate turns on. And finally, this is supposed to be memory location 2, which means that A1 is positive and A0 is negative. And you can do the same thing that you did for last AND gate IC. Connect the one that's positive, so in this case it would be A1, and just connect it directly. And since this is supposed to be negative, you connect an inverter to the other input of the AND gate IC so that then the AND gate turns on. Now I'd like to talk about the clock output. See, another modification that we had to make for our circuit was that the clock input of each of these D flip-flops had to be toggled by an address decoder and a clock output. So both of these factor into whether or not the clock input is going to be receiving any current or not. And that is why I used an AND gate, because both of these have to be activated at the same time in order for this clock input to have a current flowing through it. Now on to an equally important section, which is the data switches section. Now the job of a data switch is to basically indicate what type of data is going to be stored in each of these memory cells. Either a 1 or a 0 depending on what your inputs are for D1 and D0. And originally there were not supposed to be LEDs on this circuit for your D flip-flops, but this is good because then it easily indicates whether or not something is connected or something is stored, particularly a 1 or a 0 in the memory cell. Now, based on these LEDs, if any of these LEDs are on, that means that the corresponding commercial flip-flop is stored a piece of data. If it's not, then there's nothing stored in there. And also, another reminder is that your commercial flip-flop must have its preset and clear connected to 1, so that therefore the commercial flip-flop is then asynchronous, meaning that it is independent from this clock output. And finally, I'd like to talk about the read and write section of the circuit, where its function is to pretty much determine whether or not you will read the data, meaning that it will be outputted out here, or you will write the data, meaning that you will store new bits and new pieces of information into those memory cells. Now, when you're read and write, when this is positive, that means that it is in read mode, meaning that a current is flowing through this circuit. And since this inverter is here, this is a 0, which all the way, as you notice with the logic signals, makes your clock input 0. Now, since your clock input is 0, what happens is that whatever value is saved into that memory cell goes all the way to their respective AND gates, and then they output it out here into the LEDs out here. And when your read and write input, when that's negative, as you can see, then you can store data. You only store data if you are in write mode. You cannot store data when you are in read mode. Now, let's apply all the knowledge that we've learned over the past few minutes. Let's say that I want to turn this LED on and this LED on, which, by the way, I forgot to mention, LEDs for our project, LEDs that are green, so these two are supposed to be green LEDs, they're supposed to be associated with address 00. LEDs that are yellow, which are these two, are supposed to be associated with address 01, and LEDs that are red are supposed to be associated with address 10. And here, these LEDs are supposed to be blue. Crocklip does not have one, so I simply another just red LEDs. So, anyways, as I was saying, I said that let's try making both of these LEDs turn on. So, if that's the case, as you can see, since these LEDs correspond with address 00, both A1 and A0 must be converted to, or both of them must be in negative. So, as I just showed you, both of these have to be negative. Now, if we want to turn them on, that means that D1 and D0 have to both be positive, because then they will be stored into the memory location cell corresponding along with A1 and A0. So since A1 and A0 are both negative, that means memory location 0 is selected. And if we want to turn both the LEDs on in memory location 0, that means we have to turn on D1 and D0. Now that that's done, we have to use the clock output, or which is a push button, which is supposed to simulate a clock, or is supposed to simulate a clock pulse. And as you can see, both LEDs turn on, which is what we wanted from the start. Perfect. Now let's make the circuit go into read mode. And as you can see, both of these LEDs turn on, which makes sense. The reason why is because D0 corresponds with Q0 and D1 corresponds with Q1. And since we have one LED on uh, in one of the memory cells, and since these are OR gates, eventually you'll end up with one of these having a 1. So as you can see here, you'll have a 1, a positive, and since it's an OR gate, it accepts either or. And eventually you'll end up with a positive over here. And same thing here. If you have at least one LED on, in either one of these sections, the read or write is going to turn on regardless. So, it makes sense because if you think about it, D1 and D0 are supposed to be stored in binary. Now, since this is your digit and this is your carry, if you think about it, this is 1 1. 1 1 in binary, when you convert it to decimal, is 3. Same thing here. When you convert these two, which are both 1 1, you convert to decimal, it is 3, which makes sense. Now, that was my explanation on the 3x2 memory circuit, and thank you for listening.